Let's look at 6.5. So this section is going to provide a criteria for determining whether the requirement of a normal distribution is satisfied. So we'll look at a histogram and see if it's roughly bell-shaped and identify any outliers. But we can also create a new graph called the normal quintile plot. In our calculator or on StatCrunch, it's called the QQ plot. So the way that it works is it's going to graph two values, X and Y. X is going to be a value from the original set, and Y is going to be the corresponding Z score that is expected from the standard normal distribution. So it's going to create some kind of scatter plot. And what we're looking for it to be a normal distribution is that it is on a line, straight line pattern. If it's on a straight line pattern, then it is a normal distribution. If it is following some kind of pattern, but it's not straight, then it's not normal. So I'm going to show you some in our textbook so you'd see what it looks like. So this example, this is on page 276. So this is a histogram. And does this look like a normal distribution? Pretty close, I would say. So its normal, or its QQ plot would look like this, and it falls in about a straight line pattern. Then we have a uniform distribution. The histogram looks like that. Everything has an equal probability. And this is what the QQ plot will look like. See how it goes up and down, it waves. So since it is not straight, then it is not a normal distribution. If it's skewed, so look at how it's skewed here. It's skewed to the what, right? And this is what the QQ plot would look like. And that is not in a straight line pattern, so it's not a normal distribution.
Or like a scatter plot, right?
Mm-hmm. So we're creating a scatter plot. So I'm going to show you how to do that in the StatCrunch. So I'm going to go to one of the problems. This is number 6 on mine. Use a calculator or computer software to generate a normal quintile plot, which I'm just saying QQ plot, then determine whether the data come from a normal distributed population. So if you click here, you see your data set. So we can use this data set and open it up in StatCrunch. We can also do it in the calculator. So let me show you the steps for the calculator if you want to do it on there. You would have to put your list in your stat plot. Then you'd have to turn on, it's this last one, that's the QQ plot. So you'd have to go to Stat, Edit, put your list into L1, and then turn your stat plot on and use the last graph. I'm going to show you StatCrunch though. That is the built-in software on Pearson. So I can click this little button here, and it says click to copy table. I'm going to open in StatCrunch. And then it has all of my data points in list 1, kind of like in the calculator. And I'm going to graph this. So there's different graphs that we can do. But we want to do the QQ plot to see if it's a normal distribution. Selected column, variable 1, that's one we're using. Don't have to do anything else. We don't want a correlation. We don't want anything else. That's all we want. Compute, and it gives us our QQ plot. Remember, the X represents the original, and Y represents the, or maybe it's the opposite on this. X represents the Z-score, and Y represents the original. but it should follow in straight line pattern if it's a normal distribution. So we'd look at the answer choices and click the one that goes along with this. It looks like we can also do a histogram from this variable one. Cute. It gives us a histogram too. How cool is that? It looks close to normal, but when we did our QQ plot, it did lie on a straight line. Okay. And that is all I have for you. So you'd click the one that looks like it. It looks like the X and Y are exchanged. I wonder if I need to change something on here to make it flip the X and Y axis. Let me see if there was an option. X axis, no, it would be adding. So I'm not sure why it did it opposite. It flipped them around. Options. I'm not sure why it flipped it around. So it's just the flip of it. And then the last question would be, is it normal and why? The distribution is normal. The points are reasonably close to a straight line and do not show a systematic pattern that is not a straight line pattern. So that would be your solution there. Okay, that is all for today's notes.